Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Annelin Sindane. This lesson is proudly brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Phakama Research and Development. Our lesson for today is Euclidean geometry under the subtopic, the proportionality theorem. By the end of this lesson, you should be able to apply the proportionality theorem, solve Euclidean geometry problems using proportionality and midpoint theorems. We can refer to KEP's document, page 48. The examinable theorem on proportionality, we refer to the examination guidelines of 2021, page 7. A line drawn parallel to one side of a triangle divides the other two sides in the same proportion. Now, please note that for us to do any proofs, we need to do a construction, or we must have a construction statement. Otherwise, we will not get a mark in that particular question. It is very, very important. But for today, we are not going to do the proof. We will refer to our pre-knowledge on what we did in grade 9 and grade 10, where we did triangles and we also did ratios. We are also going to include our right-angled triangles that we did mostly in trigonometry as well as grade 10 Euclidean geometry. Now, according to our examination guidelines, for every statement, there must be a reason as you are answering Euclidean geometry questions. The theorems that are based on this proportionality theorem, we have got the midpoint theorem. We can read about the midpoint theorem and the acceptable reason we normally use the midpoint theorem. The line segment joining the midpoints of two sides of triangle is parallel to the third side and equals to half the length of the third side. We are going to see this one as we move on with the lesson. The line drawn from the midpoint of one side of a triangle parallel to the other side bisects the third side. Now, as a reason, we give it as line through midpoint to second, parallel to second side. Then, the theorem that we are mostly concerned about, a line drawn parallel to one side of the triangle divides the other two sides proportionally. This is our examinable proof, and we must know the proof of this theorem. And as a reason, we normally use line parallel to one side of the triangle, or we use proportionality theorem as the reason, but remember to name the parallel lines that you are referring to. We move on to the next theorem. If a line divides two sides of a triangle in the same proportion, then the line is parallel to the third side. As a reason, we give it as line divides two sides of a triangle in proportion. If two triangles are equiangular, we will look at this one in our next lesson. Then the corresponding sides are in the same proportion. And then also, if the corresponding sides of two triangles are proportional, then the triangles are equiangular, and consequently, we say the triangles are similar. And as a reason, we say sides of a triangle in proportion. If triangles or parallelograms are on the same base, then we are able to say, or between parallel lines, then the triangles have equal areas. This is what we use for our proof of the proportionality theorem. Now, for proportionality theorem questions, we have this to help us work in answering the questions. You have to work in one triangle at a time. You can be given the following information. You can be given information about the length, the ratio of the sides, as well as lengths, or you can be given two ratios, or you can be given one ratio, and we normally say this is a stepping up question. You will see the examples that we are going to look at. We move away to ratio and proportion. Ratio is used to compare quantities that are expressed in the same unit. In this particular case, we shall look at length. Ratio is expressed as abstract fractions. We can be given a ratio of 3/1, or we can be given a ratio 3:2. For example, we can use 3:1. That's another way of expressing our ratio. Or as given in the example, we are given a ratio as 3/1 like that. We move on to the next part where we discuss. Normally, because we are going to be dealing with line segments of the sides of a triangle, the ratios of a line segment should not be mistaken to represent the actual length of each segment. This is very, very important. You shall see this as we move on with the lesson. Now, please note that you need to make sure that we convert the ratios to actual lengths by multiplying both numerator and denominator by any given ratio by a certain constant, which we shall call K for now, but it depends on what you like. You will see as we solve problems moving forward. Now, the constants should be different for different line segments. You will see this as we approach the different questions. Let's take, for example, line AB. We are given that our line is ABC and it is divided into segments. You are able to see AB and you are able to see segment BC. AB is given as 90 millimeters and BC is given as 3 centimeters. Now, to find the ratio of AB to BC, we will first of all write it as AB to BC. We can write it as 90 millimeters to 3 centimeters. But because AB is given in millimeters and BC is given in centimeters, you cannot simplify this ratio as it is. We need to first of all convert this to the same unit so that we have 90 millimeters to 30 millimeters. After that, then can we be able to simplify the ratio as given. As you can see, on the left of your screen, you are able to see that our AB over BC, the ratio is given as a fraction, and I'm writing it in ratio form, which is the one that we are used to. Something to something, AB to BC. So I've written 90 millimeters to 30 millimeters. From there, you find the highest common factor to help us do the division. So the highest common factor of 30 and 90 will be given as, so we'll have 90 millimeters is to 30 millimeters. So what you do on the left hand side of the ratio sign, you must also do it on the left hand side. So the highest common factor becomes 30, and I'll divide both sides of the ratio sign by that. The units will cancel out, and you realize that 30 divided by 30 will give us 1, and 90 divided by 30 will give us 3. So our ratio is given as 3:1, as you can see on the given solution down there. Now, we are also going to look at our ratios in terms of sharing. I know we did this in grade 8 and 9, where we were sharing, increasing or decreasing using our ratios. If you check the interpretation, if I add 90 millimeters and 3 centimeters, this won't give me 93 millimeters as I have explained. This will give me 90 millimeters plus 30 millimeters, because we know that 1 centimeter represents 10 millimeters. So we convert the 3 centimeters to millimeters and get that 30. So we add them together. The whole line segment AC will be given as 120 millimeters. And then that is the actual length of the line. The ratio of AB equals 3 parts and BC equals 1 part. If you add 3 parts and 1 part, you will end up getting 4 parts. So that is why we are saying, if we are looking at ratios, it will give us AB plus BC will give us the 4 parts. But when you want to express the fraction of AB, it becomes 3/4. The fraction of BC becomes 1/4. And the actual line segment is going to be 20 millimeters. And you realize that for each part, it's representing 3 centimeters, which is equivalent to 30 millimeters. So if you are to find that, it will be 3 parts of AB and 1 part of BC. We move on to the next part. As indicated, we use letters of the alphabet to represent the actual length of a line. For example, if the ratio is given as 3:1 for AB to BC, the actual length of AB can be represented abstractly as 3K and that of BC as K. And the whole length of AC can be represented as 4K. And you will realize that if you are to use ratios, you are going to equate our 4K will be equal to 120 millimeters. And then if we want to find the value of K, we are going to divide both sides by 4. And we are going to get our K as 30 millimeters. So we are going to use this concept a lot as we are answering questions moving forward. And you are able to also represent our ratio of AB to BC. We can represent it as 3K is to K. And when we add, we can still write our total as 4K. We move on to the next part that we have to look at. Right. After looking at our ratios and proportions, we are going to look at now the theorem, which is examinable. A straight line drawn parallel to one side of a triangle divides the other 2 sides proportionally. And we know that the acceptable reason for this, as I have alluded to, it's the proportionality theorem as the reason, and then we give the parallel lines. In this case, we are going to say, if AD, for example, this is what we normally have to prove. You'll be required to prove that AD over DB is equal to AE over EC. Now, there are constructions that you are supposed to do in order for you to do this proof. And as a reason, you can just give it as prop theorem, and you will give your parallel lines as DE parallel to BC. That is how we are going to give the reason there. For today, we are not going to do the proof of the theorem, but you should be aware that this is examinable and it's normally 5 marks or 6 marks depending on the examiner. So please make sure that you practice this proof as it is an examinable proof. Now, we use ratios and we also use area to do this proof, but for today, I will not do the proof. We move on to the converse of the proportionality theorem. And for us to prove the converse, we are supposed to use some elements of similarity to help us prove that our AP over PB, that information will be given, and we are supposed to prove that PQ is parallel to BC. And please note, as you do this proof, you must indicate the information in your diagram as well. Ne? So that is the converse of the proportionality theorem, and we should be able to see it and apply it as we move forward. Then we have a special type of our proportionality theorem, the midpoint theorem. I know that this one in grade 10, most of us, when we're supposed to prove shapes, especially our quadrilaterals, we used this theorem a lot. And most of us ended up just writing midpoint theorem without understanding what it means and how it works. But we are going to use the midpoint theorem, but for our purposes in grade 12, we are not supposed to know the proof of this theorem, but it is done at grade 10 level. Now, the proportionality theorem and the midpoint theorem are used in most cases to prove our triangles. And if you look at the triangle that we are given, ABC, and we are given that our D is the midpoint of AB and our E is the midpoint of AC. Please, if that information is not stated, please do not assume things, because I know that is the common mistake we make with Euclidean geometry. We make lots of assumptions and we end up getting things wrong. So if it's not stated, then there should be indication using the lines that our AD is equal to DB, and also that our AE is equal to. So in this case, if you are given that diagram, you are able to deduce that our AD is equal to DB, and also our AE is equal to our EC. This as a reason you will give as given. We did this in grade 10. And then from there on, you are able now to conclude that our DE is parallel to our BC. And furthermore, you are able to also deduce that the length of DE will be equal to half the length of BC. So if they give you information about DE, you are able to get BC. If they give you information about BC, you are able to get DE as well. It works either way. Whichever information you are given, you should be able to use it to help you get your missing information that the question requires you to find out. We shall move on now to tips of solving Euclidean geometry problem. Some of the steps apply even to our grade 11 Euclidean geometry and any other question that is related to Euclidean geometry. The most important tool that you have is your eyes. And your eyes should be able to see information that is in front of you. Please analyze the diagram before you look at the questions. Identify the theorems that you can see in the diagram before you answer the question. That is the first step that you are supposed to do whenever you are given a geometry problem. Step 2, you analyze the diagram by paying attention to keywords. I know most of us do not read the information that is given as a statement above each of the given questions. Please make sure that you take some time to read that information. Read it twice before you move on and start answering the questions. Read that information. Look for information in the diagram which can be helpful and useful as we are going to write our exams. That is how our examiners catch us up. We be rushing and we end up not looking and paying attention to detail, and we end up losing marks unnecessarily. Please give yourself time to look at the diagram. Check the theorems that are in the given diagram before you look at the questions. And once you are able to identify the theorems, the reasons becomes easy for you to answer the questions correctly. If you have colors, you can use colors to mark off equal angles, equal sides. If parallel lines are not indicated, you indicate your parallel lines as you move forward. Also, look for implied information. For example, I've indicated to you that if you are having a triangle like that and you are having something, a line like that, this is A, B, C. You find out that according to the information, and then we have our DE there. According to the information, AD is equal to DB, and also AE is equal to EC. You are now able to see that AB on the other side, D becomes the midpoint of the side AB. And you are also able to see that E becomes the midpoint of AC. And you can now conclude and say that your DE will be parallel to what? To BC. That is implied information that you get by merely looking and analyzing the diagram that you are given. Some of the information will not be given, but you must make sure that you add it onto the diagram so that things become clear and you are able to deduce implied information without being told. And once you deduce that DE is parallel to BC, which theorem do you think is being asked there? Some I know have already managed to get it right. So it becomes obvious that it is the midpoint theorem because D is the midpoint of AB and E is the midpoint of AC. And you have deduced that DE will be parallel to BC. Therefore, the length of DE becomes half the length of BC. So if you are given the length of DE, you are able to deduce that the length of BC becomes 2 times the length of DE. That's part of the steps of answering Euclidean geometry questions. Step number 3, you brainstorm and develop a rough solution. You link information you have acquired. That is very important. Like I said before, Any question with a diagram is the easiest because the answer is already in front of you. So all you need to do, brainstorm, develop a rough solution as you add information to your diagram. Once you are done with that, you link your information, and then the last step, you write down a formal solution. The formal solution is the one that you submit. Please, grade 12s, always write down your information in your answer book. Do not write on the question paper as you do not submit your question paper. Write your solution in your answer book. The rough solution that you are developing, do it on your answer book, on your diagram there, and then you will write down the formal solution on the space provided for the solution down there. Now, we should look for keywords. If I may ask, what are parallel lines? Some still remember, some do not remember. If parallel lines are not indicated with arrows, some are not able to notice or realize that they are parallel lines. Parallel lines are equidistant, are lines that are drawn equidistant from each other, from the point of origin up to the point where they end. So those are parallel lines. Now, keywords, parallel lines. If the statement says parallel lines, on your diagram, you indicate parallel lines using arrows. If it says equal lines, you indicate equal lines by showing either a single line, cutting the line, or two lines if there are so many of them that are equal, so that you are able to distinguish between which lines are equal and so on. Triangle information. A triangle has vertices, it has 3 sides, it has 3 angles. You can be given information about angles. You should be able to link the information about angles to the sides. You can be given sides, you can link information about the angles. So we should be able to do that. We should know that the sum of angles in a triangle, of interior angles of a triangle, is always 180 degrees. Please do not mistake that part. We also know that the exterior angle of a triangle is equal to the sum of the opposite two interior angles. There is information about a center. You know the theorems that deal with a center. If you are given information about a diameter, you know that a diameter is a line drawn from one part of the circumference to the other part of the circumference through the center. You are able to get keywords like similar triangles. You should be able to know if they say similar, what do I look for? If you are given information about congruency, what do you look for? And that information may help you to answer the question as we move forward. Chords, etc. You know all the Euclidean geometry terms. Let's move on to the example that we have above. This is an examination type question. Can we quickly try it before I give you a formal solution? We are going to work it together, but let me give you 1 minute to look at it so that when I do it, you would also have done your own rough sketch. Is an example. It's taken from a past examination question paper. In triangle ADC, E is a point on AD and B is a point on AC such that FB is parallel to DC. F is a point on AD such that FB is parallel to EC. It is also given that AB is equal to 2 times BC. What comes into your mind? I know I recently talked about the midpoint theorem. Please, this is not midpoint theorem. So let's analyze the question. First of all, we are given our AB as equal to 2BC. What can help us solve the question here? If I divide both sides by BC, I'll be able to get AB over BC is equal to 2, and 2 as a fraction, I know it's 2 over 1. Then I'm able now to use this information of ratios. Ratios are here now. If I check, AB is that part, BC is this part. I'm able to represent this as ratios, and this will give me, for example, if I use letter X, this becomes 2X and that one is X. Because I'm using ratios, I will use a letter of the alphabet to help me represent my solution. Now, looking at that, what comes into my mind again? I'm able to see that I'm having triangles, I'm having parallel lines. It means I'm dealing with the proportionality theorem. But now I have to be careful because I have 2 pairs of parallel lines and I have to identify the triangle that I'm working with first before I'm able to answer the questions. So I can use if I decide to use triangle ACE, I think I'll be able to get the ratio AF to FE. Now, so from there on, I know that to write down my formal solution, I will have my AB over BC will be equal to my AF over FE. Remember my reason. My reason has to be stated. Now, I think my space so let me rewrite my formal solution. I'll have my AB over BC is equal to AF over FE, and I can give my reason as prop theorem. And since I'm using prop theorem as my reason, I'm going to state my parallel lines. My BF is parallel to my EC. Then I'm able to say my AF over FE is equal to my AB, back to my diagram, is going to be 2x over x, and that will give me 2 over 1. So therefore, we are able to conclude that the ratio AF to FE is equal to 2:1. That's easy. You get your 2 marks there. But it's important how you lay down your solution. It's always important that you give your steps nicely and you get your solution correctly. Now, let us look at 9.2. It says calculate the length of ED if AF is 8 centimeters. What is our starting point to help us answer this particular question? If I check, we've managed to get the ratio for AF to FE as 2:1. We are supposed to calculate the length of ED. So to solve this problem, we can indicate that our AF is 8 centimeters. Our AF is 8 centimeters. Our AF is 8 centimeters. Let's try and get the solution for ED. Let's get the length for ED. You are working on it, though we are going to work on it together. Now, we have found out that the ratio AF to FE sorry about that, is, we found it as 2. Let me use 2A, and that one will be A. Because we are using different line segments, hence I'm changing now the alphabet to A so that I do not have X and X. X applies on that side AC, and A will apply for this side. Now, let's calculate the length. So in this case, I am able to say my AF over FE will be equal to 2A over A. True or false? Yes, it's correct. It will be 2A over A. So meaning, if I'm given the length of AF, I can now easily say that AF over FE is 2/1. From there on, I'm able to substitute. My AF will be 8, my FE there, and then I have my 2/1. I can cross multiply and then get my FE as equal to 2F will be equal to 8, and then from there on I'm able to get my FE as 4. So once I get my FE as 8, what should I do next? So I will use a different color to help me get my solution. I'm taking my time. So my FE is going to be 4, meaning My AF is 8 centimeters. My FE is going to be 4 centimeters, meaning I now have the length of AE. And that length of AE, I will add my 8 centimeters and 4 centimeters, and that should give me a total length of 12 centimeters. Are you able to follow? Now, from there on, I'm able now to move on. I'm able to move on now and do the solution to help me get my ED. And we are going to do the following. Quickly. Now, if I check, for me to get ED, I need to use the bigger triangle. So I'll say in triangle, so I'll use the bigger triangle now. So I'll use the bigger triangle. Right, this technology. So in triangle ACD, that parallel line BE and CD is going to help me get the value of my missing value, the ED, and I'm able to see that I've got parallel lines in between my triangle. My solution is set. So in my next step, I would say in triangle ACD, please identify the triangle that can help you get to your solution. So my first step will be to identify the ratio that will be able to give me ED as part of the unknowns. So let's continue. You realize that my AB over my BC will be equal to my AE over my ED. My reason will be prop theorem, and I have to mention my parallel lines, and my parallel lines now will be BE is parallel to CD. Then I can substitute my AB over BC. I got it as 2x over x is equal to my AE. I've calculated it. I first of all found AF, I'm given it's 8 centimeters, and my FE is 4 centimeters. So if I added, I found that my AE is going to be 12 centimeters over my ED. And then from there on, X and X are going to disappear, and then I will be able to get my 2 ED will be equal to 12 centimeters, and then my ED will be given as 6 centimeters. Then would get our 4 marks. So the mark allocation, you are able to see that for each statement and the reason, you must get a mark. Here on the first part, I had skipped the reason. I only wrote the statement, so the reason is the same. We are using triangle ACE, and our reason is prop theorem. And we mention our parallel lines. Our BF is parallel to our EC. Then our solution is set. So for the statement and reason, you'll get a mark. For getting the length of FE as 4, you get the second mark. And then for using triangle ACD to help you get your ED again. So for the proportionality theorem, the statement and reason, you'll get another mark. And for getting the value of ED as 6, you will get your final mark. Let us look at the complete solution. As given, we are able to see the solution as is. So if you had not written down the solution, you can quickly get your solution down, and then we shall do a quick activity that you shall do, and we will mark it together. Now, before we move on to the activity will require us also to know how area works. Whenever you are dealing with different triangles, there are different ways in which you can calculate the area of a triangle. The most basic formula is area of triangle is given by a half base times perpendicular height. We all know this one. But sometimes you will find out that the perpendicular height can be constructed inside the triangle. For example, if you are looking at triangle ABC, the height is constructed inside triangle ABC. And then you also have triangle BDC, where the perpendicular height of triangle BCD is constructed exterior. It's outside the triangle, but you'll realize that the base BC is common for both triangles, and the height is going to be the same because these are between parallel lines. We use this information when we do the proof of the proportionality theorem. Now, as well, we are going to use this concept when we are finding the area of triangles, where we are applying the proportionality theorem to find the ratio of the areas of the given two triangles, and so on and so on. Also, if you look at triangle PQR, the height is constructed inside the triangle, but you are also able to see that QR is equal to BC. The area of these triangles is going to be the same because QR is equal to BC. The base is equal in length, and because of the parallel lines, the height is going to be the same. And we use this concept when we are proving the theorem. Line drawn parallel to one side of the triangle divides the other two sides proportionally. And as we move forward, you are going to use this now to help us find the ratio of areas as well. So please take note of that. we move on to the next part. We move on to the next part. Right. I'm going to give you some time to do activity 1. Okay. Now, there's one slide that we need to look at. Right. Whenever we are using proportionality questions, we have got area where we are supposed to find the ratio of areas or find the area of triangles. I've explained the common angles where we use the area rule. We know the area rule, that our area of triangle, for example, triangle ABC, will be given by half. If I have my triangle like that, if that one is A, that one is B, that one is C, small letter C, that side, small letter B, that side, it will be given by half AB sine C. We remember the area rule from grade 11, which is also AC sine B. We are going to use this a lot as we are answering the questions and also half. So we should be able to recognize the type of triangles that we are dealing with and which area rule to apply. Also, we shall also be looking at a common height to find the area of triangles. I've explained the common heights in the previous slide, and also between parallel lines, and also when we have a common vertex. That is when you will see that they will cancel each other as you move forward, and you are also going to be able to get the ratios using the sides. Now, let's look at activity 1. I'm going to give you some time to look at activity 1. Let's read the information given. In the diagram, we've got triangle ABC with points D and F on BC and E on point AC, such that EF and AD, EF is parallel to AD and DE is parallel to BA. Further, it is given that AE over EC is 5/4 and DF is given as 20 centimeters. You are able to see the ratios are coming in there. Ne? Now, let me give you the questions to answer. I'll give you 5 minutes to answer 3.11 and 3.12. There is the diagram next to it, and then we are going to mark it together. we've enjoyed the question. Now, let's quickly do it together. We are given information about AE and EC. So if you check AE, EC, this will give us our 5A and our 4A. And we are also given, so the triangle that is going to help us get our solution is triangle ADC. I've highlighted the triangle. Are you able to recognize parallel lines? Yes, I'm able to see that my AD is parallel to FE, and I'm given information about DF as well as that. So this is straightforward question. Let's write down our formal solution. We are given that our, let me start with FC over my DF. FC goes with CE or EC over my EA. Like that. My reason become prop theorem. And don't forget to mention the parallel lines. I have my AD being parallel to my FE. That's my reason. From there, I substitute. My FC is 5. My FC, I don't have my FC. Sorry about that. I don't have my FC. So it has to be so I'll start afresh. Quickly, 5A, 4A, right. So I said FC over my DF is equal to my CE over my EA. My reason is prop theorem, and I mentioned my parallel lines AB. AD is parallel to my FE. Then I'm going to substitute my FC. I don't have the information. My DF is going to be 20 centimeters. My CE is going to be 4A, and my EA is going to be 5A, and this will give my FC as 4 over 5 times 20 centimeters, giving my FC as 16 centimeters. I get my full marks there. Then 3.12, add the information into the diagram. FC, we got it as 16 centimeters. So in short, we are able to get the length of DC as 36 centimeters, because we are going to add our 20 and 16 to give us that 36 centimeters. Now we are supposed to find BD. If I look again, I have triangle ABC is the one that is going to help me. And I also have parallel lines, AB and my DE. So using those parallel lines, I'm able to say my BD over my DC is equal to my AE over my EC. Again, this is prop theorem, and I have to mention my parallel lines, AB parallel to DE. Don't forget to mention the parallel lines. Then I'm going to substitute. My BD is unknown. My DC, I calculated it as 36. And my AE, I found it as 5. And my EC, sorry, it's 5A. And my EC is going to be 4A. And my BD becomes 5 over 4 times 36 centimeters, and this will give my BD as 45 centimeters. And I will get my full marks again. I get my mark for the statement and reason, as well as substitution, then I get my solution. Let's move on to 3.2 quickly. We have our 3.2 there. That is where we are going to use our area now. Can we quickly do that one? I'll give you 3 minutes to do 3.2. Welcome back. I hope it was easier for us to quickly go over it. I'll quickly add information as well that we're given and that we have calculated. We said our AE 5A, our EC 4A. FC, we calculated and we got 16 centimeters. Now, we calculated BD and got it as 45 centimeters. It is important that we always add information to our diagram. Now, let's identify the triangles. We have triangle ECF. I'll use the same color for now. I have my triangle ECF, and then triangle ABC is the whole bigger triangle. What do you realize about the triangles? Remember, we said whenever we are calculating areas, we should look for common vertices, or we have a common height. In this case, what is it that we are having? Yes, I can see. We are having a common vertex, which is angle C. So we are going to use the area rule. In this case, the area of triangle ECF will be given by half. What are the common vertex in this case is going to be angle C down there. Ne? So it will be half of EC times our CF sine of our angle C over. For the area of triangle ABC, again, we realize that we have got a common vertex, which is C, but now the sides that emanate from vertex C are AC as well as BC. So to find the area of that triangle, it will be given by half. We said it will be half CA times CB sine C. You realize that sine C is common. We can cancel that one. Half is common. We cancel half. We are left with EC. Let's go back to the diagram. What is our EC? Our EC is going to be 4A times. What is our CF? Our CF, we calculated it and we got 16 centimeters. We substitute it with units so that we are able to see what is happening. And then let's look at the bigger triangle. Our AC or CA is going to be 9A because we are adding 4A plus 5A. It gives us the whole length in terms of ratios as 9A. And if you look at the length of our BC will be given by 45 plus 20 plus 16. And that gives us 45 plus 36, and this should give us 81 centimeters. So I'm now going to be able to substitute my AC. I calculated it and I got 9A times. What is my BC? I got it as 81 centimeters. My A and A will cancel out. My centimeter and centimeter are going to cancel out. And this should give me 4 times 16 will give me 64 over. That's 81 times 9 will give me 729. And this will be my answer for getting the ratio of the areas there. It was an easy one. Ne? Let's move on to the next one. Now, let's do that activity. I'll give you some time to look at the diagram. In the diagram below, AB is 3 centimeters, BC is 4 centimeters, AE is 2 centimeters, and ED is 6 centimeters. Determine the ratios of the following. I'll give you time to answer that one. I'll give you 5 minutes, and then we are going to do it together. Right. I hope we have had a wonderful time doing this question. Let's quickly go through the solution. Now, the area of triangle ABE over area of triangle ACE. Let's identify the triangle that we are going to work with. Now, I will highlight triangle ABE, and I'll also highlight triangle ACE. Again, what do we realize about the two triangles? They are having a common vertex, which is A. So I can use area equals to half. If you check, it will be half. Looking at triangle ABE, it will be half AB times AE sine A over half. If you look at triangle ACE, you are able to see that you have got your AC times your AE sine of angle A. Then, if you check, half and half is common, sine A and sine A are common. What is AB? You just take from the diagram, it is 3 centimeters. What is AE? It is 2 centimeters over our AC. It's going to be 3 plus 7, we get 3 centimeters multiplied by our AE, which is also 2 centimeters. So our final answer in the form of a ratio, centimeter and centimeter will cancel out and we'll get an answer of 3/7. What is the alternative way of doing this one? If you want, you can construct a perpendicular height from AB to E. I'll use a dotted line and I will have that as a height. And then this is the alternative solution, or it will be equal to half. If you look at triangle ABE, our base is going to be AB times the constructed perpendicular height over, if you look at triangle ACE, because the height is constructed from AC to the vertex E, they are going to share a common height. It will be given by half. You are able to see half AC times our perpendicular height H, and half will cancel out, and then we'll get our solution as AB over AC. And let's check, our AB is also 3 centimeters and our AC is going to be 7 centimeters. So either way, we are getting the same solution of 3:7. That's how we do the calculation there. We move on to 1.2. We want the area of triangle ACE. Again, let's highlight our triangles. It's important that we highlight our triangles. And triangle ADC. Again, we are also having a common vertex. So area of triangle ACE will be given by half. We have our AC times our AE sine A over triangle ADC. It becomes half of our AC times our AD sine A. Sine A, half and half will go. What is our AC? We are taking it from the diagram. AC, we have calculated it, it's 7 centimeters. What is our AE? Is 2 centimeters over. What is our AC? It's still 7 centimeters multiplied by 8 centimeters. And when we simplify this, we'll get 1/4. We get 1/4 as the solution to this question. We move on to 1.3. We are having triangle ABE. We highlight ABE over the area of triangle ADC. Now, for this one, the solution is clear. We are able now to follow the same format that we did for question 1.2. We have identified our first triangle ABE, and then we have also identified our triangle ADC. And again, we have got a common vertex. It is going to be half. We are going to have AB times AE sine A over half. We will have our AC times our AD sine A. Then we know what's going. Our AB, we are reading it from the diagram, is 3 centimeters. And our AE is 2 centimeters over. Our AC is going to be 7 centimeters. And our AD is going to be 8 centimeters. And this is going to give us 6/56, which is the same as saying 3/28 as our solution. Now, let's move on to question number 2. I'll give you question number 2 as a homework because I can see that time is no longer on our side. Let's quickly copy question 2 as our homework, and we should enjoy that question as we copy it. We are going to do it in our places wherever we are. It says the sketch below shows PQ parallel to RS and PT parallel to QS, with AQ equal to 8 centimeters, AP equal to 9 centimeters, TS equal to 7 centimeters, and RT equal to 13 centimeters. Determine. You need to find RP first, then you find QS, and then you should determine the area of triangle APQ over the area of triangle RPT. Now, I hope you have managed to copy the question because time is no longer on our side. We shall move on to the next part of our lesson. Now, I hope this lesson helped you to use proportionality theorem to solve problems involving triangles in Euclidean geometry. The midpoint theorem, you have realized that it serves as a special case of proportionality theorem. And the examinable theorem on proportionality, we know that a line drawn parallel to one side of the triangle divides the other two sides in the same proportion. Please, you must know the proof of this theorem, and you must always know that the application of the converse theorem of proportionality can be asked, and you must know how to use it and to give the correct reason for using that particular theorem. The reason must have converse prop theorem. I hope we had a good lesson of wrapping up our proportionality theorem. Thank you very much. Enjoy the rest of your afternoon, hoping to meet again in our future lessons. All the best for exams. Please, let's keep on keeping on, and we always do our best. Yes, we sanitize, we wear our mask indoors now, and please, let's maintain our social distance, keep safe, and see you next time. Goodbye.